Hello everyone. Today we will be discussing Chef and Stone's problem of December 2015 long challenge. In this problem, we were given two numbers that denote the number of stones in a particular pile, and also we were given one more number m. So let's understand the problem by taking examples. Let's say A is 4, B is 5, and M is 5. So this tells us is that there are 4 stones in pile A, 5 stones in pile B, and M is the number of moves. That is, if M is 5, then we can have moves from 1 to 5. That is we can remove one stone from both of them. We can remove two stones from both of them. We can remove three stones from both of them. The main aim is to empty the piles as much as possible. So for this, M plays an important role, because let's say we need to empty pile A. So pile A is having 4 stones. So and we have this many options, but this options can be applied only once. That is, if we remove one stone from both of them, then we can't remove again one from both of them, right? So for this, we have to check if we can empty the entire pile or not, and the answer is whenever the summation of this, that is 1 to 5, the summation is 15. So whenever 15 is more than A, more than the minimum among them, so that tells us that we can represent the minimum as summation of this. That is, say 4, so we can represent easily as 1 plus 3, right? Or say 5, we can easily represent as 1 plus 4 or 2 plus 3. We can easily represent all the numbers from 1 to 15 as from by using this many options once. So the remaining stones for this case would be 0. Why? Because we can entirely empty the minimum pile. Yep, minimum pile is A, so we can entirely empty it, right? By applying 1 plus 3. That is, first we empty one stone from both of the piles, then we empty 3 stones from both of the piles. So remaining stones would be 0, and the final answer would be 2 into the remaining stones plus difference. Why? Because n here is the remaining stones for a particular pile, that is a minimum pile. Here the minimum is 4, so we are considering pile A. So for pile A, the remaining stones is 0. So for pile B, it would be the number of remaining stones plus difference. So we can represent it as 2 into n plus difference. Your difference is 5 minus 4, that is 1. So our answer would be 2 into 0 plus 1, that is 1. Now let's take another example. This will tell us the importance of m. So we are taking same values of A and B, but m is 2 here. So what this tells us is that we can use up to 1 to 2 different moves. That is, we can first empty one stone from both of them, then we can empty 2 stones from both of them. So the summation here is 1 plus 2, that is 3. So we can't represent 4 from this moves, right? So n here would be the minimum among this. So minimum is 4 minus the summation of this. So summation is 3. So 4 minus 1, that is 1. 4 minus 3, that is 1. Now this was for the pile A. For pile B, it would be this remaining plus the difference. So difference is 1. So we can represent it as 2 into n plus difference. So n here is 1. So 2 into 1 plus 1, that is 3. Let's understand the code. So we are taking input a, b and m, and this part is when a is less than b, else this part, that is b is less than a. So let's suppose a is less than b, as in our case 4 and 5. So we are passing the minimum value, that is your a and m, and we are calculating, passing that function, passing it to the function compute. The function compute is calculating us the value of n. So the condition here is we calculate the summation of m. So for this case it was 15, for this case it was 3, and we check it if it is less than equal to a, that is whether we can represent a as from this different moves or not. If not, that is b is less than equal to a, then we return the difference between them, else we return 0. That is, if it is less, b part, that is summation is less than the minimum value, then we return the difference, else we return 0. And then in the main function we are calculating 2 into n plus the difference. The difference would be, as b is more than a, b minus a plus 2n, and here it would be 2n plus a minus b, and just we are then printing